Hello and welcome back. I'm Matthew, and this video is part 5 in our series on installing MVS 3.8 into our Hercules emulated mainframe using J. Mosley's instructions. I suspect this will be a relatively long video, so we will go ahead and dive right in. At this point, our prerequisites should be complete because we've been following these instructions step by step. And you can see now we are using a significantly different hardware configuration. Of particular note is that we are now switching over to a 3270 console instead of that line-oriented console we had before. I think in the most recent starter system configuration, we were using a 3215 printer keyboard device. We also have more of our DazD devices that we'll bring online. In fact, we're going to create more and add to the system from before. But we also have all of our 3270 sessions that will be our VTAM devices where users can log in and use TSO, which is pretty exciting. We're now at the point where we can have end users interacting with our system. One important point to note, and we'll look at this in the Hercules configuration, is that the 3270 devices are defined in this Hercules configuration with group names. In this case, the group name console will connect you to the 010 device, which is our master console for MVS. If you'll remember from the previous video, the Sysgen macros where we specified the master console was at address 010, so that's where we need to put it. And then the TSO 3270 devices are defined with the group name TSO. So what all of this means is that if I'm using my 3270 emulator, for example, I'm using C3270, which is part of the X3270 project for Linux, or if you're on Windows using Tom Brennan's Vista 3270, which is the emulator I recommend if you are a Windows user, you will need to provide the LU name or the logical unit name to get attached to the right device in Hercules. This way I can open up one session, and if I connect with the name console to Hercules, I ensure that I get connected to the 010 device. If I connect with the name TSO, I ensure I get connected to one of these 8 devices defined at addresses 400 through 407. So we'll take a look at that, but I just wanted to point that out here. Given the Hercules configuration that's provided, you will need to specify an LU name in your 3270 client. If your 3270 client doesn't support LU names or you can't figure out where to put them in, that's also okay. We'll see in the Hercules configuration file, we can just delete the group names, and then Hercules will just attach your sessions to the devices in order. So the first device you attach will go to 010. Any subsequent devices you attach, or emulator sessions, I should say, that you attach, go to all of these additional devices. All right. So we are going to start Hercules up with that mvs.cnf file, and we're going to connect with our 3270 emulator instead of just telnetting to it like we were to the starter system. So let's switch over to our console and do that. In Hercules, and I want to show you one more time because this is an important point that could trip you up when you're working with Hercules configurations. Let's look at that mvs.conf file. And you can see we have our card reader is now actually listening on a socket. We'll talk about that in a minute. And we have another card reader that we'll still be able to feed files to. We have some printers. It looks like based on the comments, several of them are managed by JES2. So these might be for different output classes. We'll go to a different printer. We also have another printer, and this is going to... this is a punch, so we'll be able to have punched output. We have DazD devices, some of which are commented out. These will be used in our system after we create and initialize these additional DazD devices. We have another printer where a hard copy log of the master console will go. We'll look at that in a minute. But here are those 3270 entries, so the display terminals. The master console at address 010 has the group name console. And this is what makes it so that Hercules requires that name be provided in the 3270 session in order to connect you to this 010 device. Similarly, we have 8 3270 devices starting at address 400, and these have the TSO group name. So you have to provide that group name. Again, in the 3270 clients, it's usually called the LU name. You have to provide that when you connect to Hercules with your 3270 emulator if you want to end up getting attached to one of these, in this case, 8 devices. Now, if you don't want that, I can just remove those group names from the Hercules configuration file. And now I don't provide any LU names, and Hercules will simply connect me in order to the 3270 devices that I have defined. So if you can't figure out how to provide an LU name with your 3270 client, you can just remove those group names and connect in order. I typically don't bother with the LU names because I don't have any differentiation of my various TSO sessions, and the MVS console is always just the very first connection I make. But for the sake of this example, I'll leave those names in, and then we'll see the connection to the different group names. All right, so let's start up Hercules with our conf/mvs.cnf file. And now our previous console session we had called our 3215 console. Well, we're not using a 3215 emulated device anymore. This will be our full screen-oriented 3270 console. So to try and keep us not too confused, I'm just going to rename this tab. We'll call this our MVS console. So this is our MVS operators console. And we are going to have our kind of end user TSO session. So let's rename this tab from shell to MVS TSO. And then I'll create a new session because we're still going to need to do quite a few things in the Linux shell at this point. So Hercules is running. Again, I'm not going to telnet localhost 3270. We're now going to use our 3270 emulator. So I'm using C3270, which is a command line or console, text console based emulator. And I will connect as console at localhost on port 3270. And again, this is that important point about needing to provide the group name I'm connecting to. And the way you do that in C3270 is you do group name or LU name at the host you're connecting to. So this is going to be my console session. I want to connect to that 010 device. So I'll run that. I get a Hercules splash screen here, and I can confirm that this 3270 emulation is connected to device number 010 on my Hercules mainframe. Similarly, we'll connect our other session here with C3270 to the TSO group. So TSO at localhost, port 3270. And we can see we got connected to device number 400, which was the first of those TSO devices. So back to the instructions. We have our connection made. We have our console connected to Hercules, so we're ready to start the system. We will IPL 150. And I want to point out, not Control A, I want to point out that we have been using IPL 150 or 150 to start up the starter system. But in Hercules now, I'm going to hit escape so we can see our list of devices. Now, device 150 is our MVS Res DazD device. And in fact, all of our DazD devices are volumes that we created that are not that starter system. So we're no longer using the starter system. We have reconfigured this mainframe hardware such that our target or our device for address 150 is our new target system residence volume, our MVS residence volume. And then we have our other volumes that we created here. So the starter system is no longer in the picture. This is the first time that we are IPLing that new system that we generated. So very exciting stuff. I'll hit escape. We will IPL 150, hit enter, and I'm going to switch to the MVS console. And you can see now we're being prompted, specify system parameters for release 03.8.vs2. So similar to what we saw when we were starting the starter system, although the starter system was MVS 3.7, and we had that 3215 device as our console instead of our nice full screen 3270 device. So let's go back to the instructions. And it looks like in this case, because it's the first time we're starting up our new system, we do need to rebuild that link pack area. So we will use the CLPA option as our startup parameter. So back to our operator console here, specify system parameters. Because there's no number here, it's implied that we just need to reply to message 0. So R0, comma, CLPA. You might have noticed before it flashed away some errors there. If we look back at the instructions, there's a note that those are to be expected. Those modules aren't required for the operation of the system, and so we should not concern ourselves with those messages. So I will go ahead and not concern myself with those messages. Another thing to note here, in the example provided by Jay Mosley, the first question that's outstanding that needs a response was the IPL reason, subsystem ID, or U to just continue without providing that information. If we look at my system, that message isn't there. Our first message, which is going to be reply ID 0, are the JES2 startup options. The reason I don't have that message about IPL reason is because you'll recall in the previous video, in the control program Sysgen macro, we removed the, I forget what it's called, the error recovery or error logging, whatever that option was that enabled some various error recording information in our system. Now, I do that because, again, this is not a real production hardware system where I'm working with IBM on any reliability problems I'm having. So I don't really feel the need to have that in my emulated system. One of the side effects of not including that error logging capability of MVS is it doesn't ask me on an IPL, hey, why is the system being re-IPL'd? This should be a stable system. You shouldn't have to reboot the system except for a pretty good reason. So by not including that function, it doesn't ask me for that information at startup to record in the error log. If you kept that, if you followed the Jay Mosley instructions to the letter and didn't make the modifications that we talked about, you can go ahead and reply to what your message 0 will be with a U, and then your message 01 will be your JES2 startup options. In my case, the first message is just the JES2 startup options, so that's my message 0. So back to the instructions. Again, you can see I didn't get this line. I'm just down on the JES2 options now. Because this is the first time we're starting up JES2 on the system, we'll do a JES2 cold start. We'll format its data areas. So I will do an R with format no rec. So back over on the console, we'll R0 format comma no rec. Now, because this is a new spool area for JES2, it's saying there's an IO error. That's just because it can't find the data it's expecting. So we do want to continue. We'll reply 1 Y. And then it's asking us to confirm that as part of the cold start, we're changing the checkpoint record. That's fine. We'll reply 2 with Y. Okay, so JES2 cold start in progress. Spool 1 is being formatted. And now you can see we have this message waiting down at the bottom. So by default, the MVS console will pause here because it's concerned you may not have read all of the messages up here. It's not going to scroll these messages off the screen to show new messages until it's sure that you have seen everything that the system wants to tell you. Now, that's kind of annoying. The system will eventually stop processing because this message buffer can fill up and the system won't be able to proceed with anything it's doing because it's going to be waiting to print data out to the operator console. So one of the things that was set up in our Sysgen process, we ran those job streams that created a bunch of parmlib members. One of those parmlib members was the function keys for the MVS console. And if we look back at the instructions, this is explained in a bit more detail here. You can see we get to message waiting. we can set up our console options into roll delete mode, and that will cause the messages to just go ahead and roll off the top of the screen to make room for new ones. Now, there's a command to do that, but it's kind of annoying to have to remember that. And again, if you're not IPLing your system frequently, you may not always remember that. But that PF key setup created a macro for us where we can just hit function key 12 and it will issue the command to get us into roll delete mode. So let's go ahead and do that. I'm going to switch back over and I'm just going to hit F12. Now our console mode is roll delete, and you can see messages just scroll off the top of the screen as new messages come into the bottom. And we finished IPLing the system. We're up and running, and our system is ready to do work. Now you may ask, well, what if I want to see all those messages that rolled off the screen, right? There could be a lot of messages very quickly, and I might miss important information. There are several options to view that. One, once our system's up and running, we can install a program like imon. And one of the features of imon is that it can display the MVS console log and actually interact with the console. So you're able to issue console commands from a user session instead of having to have physical access to the console. We're not going to do that in this video because this part of J. Mosley's instructions don't install imon. That will just have to be something we do on our own. So maybe that'll be a video down the road. But the other option is that everything on the MVS console is also being printed to a specific printer device. And that printer device in Hercules is being output to the file mvslog.txt. So if we look at our mvslog.txt, we can see all of the messages back to the beginning of our IPL and our reply there that our MVS console produced. So I can always go back and see those messages if I need to diagnose a problem or troubleshoot something where that text scrolled off the top of my console too quickly for me to read. All right, back to our instructions. I'll also add, these are invaluable links that are in the instructions here. These are a summary of the console commands for this MVS console. So they tend to be relatively cryptic, single letter commands that, unless you're really used to them, may be difficult to remember. We also have the JES2 commands here. So these are the commands to release jobs, cancel jobs, stop jobs, start initiators, interrupt printing. You'll want to keep these pages close at hand and bookmarked because they include a lot of good information about everything that you can type into this MVS console screen to manage your system. Okay, the first thing we need to do is add this additional DazD device that Jay has put together for us. And this disk has all of the, or certainly a lot of the freely available compilers from the era, as well as additional utilities and programs that have been produced by both the emulation community, but also the mainframe community at large since that time frame. So the easiest way to get that is just to download this disk that has all of these extra programs already on it. And then we'll integrate that into our system and we'll be able to use everything that is on this disk. So let's go ahead and copy the link to that DazD file. And I'm going to move over to my shell here into my downloads directory, and we will download that quickly. Okay, that was indeed pretty quick. And then if we look at the table of contents of that tar file, we can see that it will unpack into a directory called DazD. So if I go back up to my root directory of my MVS system here, where I have my DazD directory, my tape directory, etc., if I extract that tar file right here, that syscpk DazD image will go into my DazD directory, and we can see it there. Now, one quick optional note here. You'll note that this file is larger than my other DazD images. Remember, one modification I made was to the DazD create script. I added the -z option to DazD init, and that creates my compressed DazD files, my CKD files. This is a regular uncompressed CKD file. that's fine. What is this? 320 megs isn't really going to break the bank on any of our modern systems. But just for consistency, and in case I want to use features of CCKD, if I could speak, CCKD files in the future, such as shadow files and volume snapshotting, which may be the sort of things you're familiar with from something like VMware, we're going to convert this into a CCKD file, a compressed CKD file. Totally optional, but again, I'm just going to do it for consistency on my system. So there's a Hercules executable that gets installed with Hercules called DazD copy, and I can provide it many of the same options that DazD init takes. So I'll give it the -Z option, which in the case of DazD copy is actually the default. And then I provide the input file, so my syscpk.3350, and then my output file, and we'll just call it syscp.3350.new. And that will simply copy this DazD file to a new DazD file with whatever different options I've provided to the DazD copy command. So that'll go pretty quickly. And now if we look at our files, you can see that sure enough, the compressed DazD image is smaller. So I'm just going to move this compressed file over top of the original file. That'll replace it. And now I have, once again, nothing but CCKD files. Again, personal preference, totally optional, but it's just something I like to do. So we've downloaded that. We've converted it, in my case, to a compressed DazD image. We're going to create additional volumes. So we want a pub 000 volume, which will be a 3380, and a pub 001 volume, which will be a 3390 volume. It looks like we're also creating 6 sort work volumes. These are very old device types, 2314, so old small DazD. But the sort merge program that is available to us in MVS 3.8 is a very old version that doesn't know how to use disks newer than the 2314. We don't have any newer version of sort merge freely available to us. So we're just going to create a bunch of small work volumes, and together they'll give us a decent amount of space to do our sort and merge operations. So we'll use that create DazD script. We're now creating the user volumes. So we have that script from last time, create the user volumes, and you can see that created, it looks like 8 volumes for us. So now we need to attach those 8 volumes to our emulated mainframe. Again, Jay has provided us a nice script that will just run the commands in Hercules that we need to attach those devices. So again, this is similar to our previous steps where we started Hercules without the devices attached. Then once the MVS operating system was IPL'd, we attached the devices, and then we're going to initialize and mount them. So script conf mvs.script. This is a Hercules command, so we're in the Hercules console. And it looks like it successfully attached those 9 devices, the 8 we created, plus that system compiler pack. And this is the other big change in this step relative to previous steps. I'm going to scroll back up to our hardware definition here. So our card reader in this system at address 00C is set up in Hercules to listen on a socket, a network socket. So I'm able to submit jobs over the network. In this case, it's just listening on my localhost device. I may need to change that to my actual IP address or the 0.0.0.0 address if I want to be able to do it remotely. But whatever network device I bind to, Hercules will accept network connections, and you're able to then stream in job streams to Hercules, and Hercules will present that input to the emulated mainframe as if it were data loaded into a card reader. So it's just 2 different ways of doing things. We saw the file-based method where we would do dev init, the card reader address in a file, and then ASCII EOF to the Hercules console in the previous steps. This way lets us do that without having to interact with the Hercules console. Again, maybe I want to set myself up to do that from my desktop PC so I don't have to SSH into my Hercules session and connect to and bring up the Hercules console and run the dev init commands there. So the way we submit jobs is going to be through that submit shell script that we created or modified in the preliminaries video in part 1. Let's get back down to the appropriate part of the instructions. In the case of the batch file that came with the JMosley download package, that uses the netcat command and redirects standard input from the %1 parameter. Well, that's DOS batch file syntax. On Unix, we modified that and made our own script. If I go to my shell, we made that submit script that uses the netcat utility and it redirects standard input from the $1 parameter. And that, again, is the first parameter we pass into this file. So I'm able to run the submit script. And again, I can't just type submit like the instructions say, because that's DOS-based or Windows-based, where that would just run the submit.bat in the current directory. I need to say, I want to run in the current directory, run the script called submit.sh. And if we look back at the instructions, the first script we're going to submit is our MVS00.jcl. This will initialize those volumes and then submit a command to vary the volumes online and mount them. Again, this is a Windows-oriented syntax. We're going to say submit sh jcl /MVS00. So let's go over to our console and complete that command, jcl /MVS00.jcl. And again, this submit script is simply going to stream this JCL into this netcat program, which will in turn stream that data to localhost port 3505, which in turn Hercules will pick up and present to our emulated mainframe as card reader input. So that's hit enter there, and all of that will happen. Now, if we look back at our MVS operators console, you can see that sure enough, we received that job stream on reader 1. And as with all of our previous steps, we're initializing some volumes here. So we need to confirm that we want to make a change to volume 180. This is message 3, so I'll reply 3U. And because we're initializing 8 volumes here, there's going to be 8 of these messages. So I'm just quickly going to reply U to each of those messages. Okay. So you can see after we initialize, though, we all have mounted all of those volumes as well. Before, when we had a job that tried to issue the operator console mount command, we were prompted, do you want to run these commands? So we were still prompted if we wanted to initialize the volume, because that's a potentially destructive operation. Or it's always a destructive operation, but potentially a destructive operation that you don't actually want to run. The operator console command to mount is because we submitted this new job through a job class that was set up in the JES2 options named class S. And class S has special permissions, or it's just configured to run any of the console commands without prompting for confirmation. So we can read about that here. And in fact, there's quite a big description here of the job classes that are set up in the system, the initiators that are running them. And you can read more about that setup and the output classes. For example, we have a punch output on class B. We have a printer output on class A and M, which are 2 different printers. So those go to 2 different files that Hercules is emulating those printers at. And this was all set up in that JES2 PM00 member in sys1 parmlib. So you'll remember we changed the job stream that created this member to remove the requirement to include a programmer name and account number in the job card. But there was a lot of other stuff being set up in that member as well for all of these different input classes, job classes, output classes, initiators. So you can go back later and look at that sys1 parmlib member, JES2 PM00, along with the JES2 documentation and the description that Jay has provided here, if you want to start getting a picture of how that all pieces together. Another important step, we are using that MVS.cnf configuration file to start up Hercules. That is the configuration file we will use from now on. So we want to go ahead and edit that file to uncomment the lines that will allow us to then include all of those new devices we just made, so that the next time we start the system up, we start Hercules up, those files will be there. So let's go back over to our shell, and we will edit that file before we forget, because the system, not JCL, sorry, conf mvs.conf, the system will not IPL successfully in the future, because we're going to start installing some things on the system and making some changes to the system that require some of the data that we're going to put on these extra volumes. So let's remove the comment line on all of these commented out DazD entries, including that system compiler pack, now that we've downloaded it and put it in our DazD directory. Our alternate console is still commented out. We can leave that commented out. That would be in a real world scenario if you had two physical consoles, right? If one goes offline, you don't want your whole system to go down because you've lost your master console. So you can have an alternate console. In my case, because it's running on the same system connected locally, if the console goes offline, I probably have bigger problems. So one console is enough. But again, you remember in the Sysgen job stream phase 1, we had the alternate console defined to our system on device 9. So that's there if you need it. Okay, I've removed those comment lines for the DazD. We can save that file. The other thing I'm going to do, because this is the file that we're going to use forever to bring up this particular emulated mainframe, I'm going to copy that from the conf directory to my base directory and call it Hercules.cnf. Now, and I'm not going to do it because I have Hercules already running over here, but now if I just run Hercules with no configuration file option, it will use the file called Hercules.cnf in the current directory. So in the future, instead of having to say Hercules-f conf/nvs.conf, I can just run Hercules and we'll be using that correct configuration for our new emulated mainframe. Obviously, this is bigger text. This is bold. It's in a red box. You don't want to forget to uncomment these volumes from your configuration file. Another piece to note, you can read through the details here, but notice that because of one of the user modifications we installed during the previous video in the Sysgen steps, if I look at my MVS console, as jobs run, I am now getting the condition code or completion code for each step of the job as it happens printed out to my MVS console. In this case, there was an ID cams job. It completed in, what's that, 200ths of a second, and it had a completion code of 0, which is what we like to see. So this is really convenient because instead of having to go back to that printer output and look at your job output to see what happened, if you happen to have your console open in another window or on another screen, you can just see the output of the condition codes right here in the console. So really great addition to the system. And here's the explanation of what does each of those fields mean. You can run through that if you're interested. All right, user catalogs. This is another extremely important topic. You should read through this. You should probably even read through elsewhere on Jay Mosley's site. He has a tutorial on this topic, I think on vSAM in general, but I think in that he also covers catalogs and user catalogs. The basic idea here is you don't want to catalog very much to your master catalog. Any user data sets, a lot of the stuff that you add to the system, really most new data sets, you want to catalog in user catalogs and create aliases so that the high-level qualifier you're using for that new data set doesn't get cataloged in the master catalog, but gets cataloged in a user catalog. So what this job does is it's going to set up some space on that pub 000 volume we created, and the pub 001 volume we created to allocate some vSAM space. So if you want to get into vSAM, which is a whole nother topic, you'll be able to have just a big vSAM cluster on this large 3390 volume. But also, this job is creating user catalogs on pub 000 and pub 001. Finally, it will add a password to the master catalog, and that password will be sysprog or prog, however you say it. So what this means is going forward, after we run this job, anytime anything tries to modify the master catalog, typically that will be in the form of cataloging a new data set, deleting or removing a catalog entry for a data set, or adding an alias to the master catalog pointing to the user catalog. Anytime we try and modify that, the system will prompt us for the password on that master catalog. So that way, users who don't have permission to add things to the master catalog or to modify the master catalog won't be able to do so because they won't know the password, or perhaps won't have access to the MVS operator console to even enter the password. Now, in our case, this is most likely a single user system, and I own the system and I have permission to do anything. This is still a good thing to do because I will notice if I accidentally try to catalog something that gets cataloged in the master catalog instead of a user catalog, which is where I'll almost always intend my personal data sets to be cataloged. So by having this password on here, if I see the system prompt me for the password, I'll think about, oh, did I mean for that to go to the master catalog, or do I want it to go to the user catalog? So let's go ahead and run that MVS 01 job. We'll go back to our shell. We'll use that submit script, and we'll submit MVS 01.jcl. And watching the system console, the job came in. We ran an ID cams job. We got a completion code of 0, and that's what we wanted. So at this point, we can assume that worked correctly. If we go back to the instructions, you can see we can still use the concode script to check the printer output, but we already saw that the one step of this job had a completion code of 0, so we don't need to go check the printer output again. We already saw that on the console. All right, this is getting fun because now we get to add our own TSO user. So let's edit this MVS02 script. So back in my shell, we'll open up JCL MVS02.jcl. So this is our job to add users. You can see here it's adding 2 users, HMVS01 and HMVS02. The parameters for this procedure are documented down here. So it takes the user ID, it gives you the restrictions on that, password or asterisk if you don't want a password, the account number, probably not something we're going to be using in our personal single user emulated mainframe, and then whether the user has the TSO operator privilege, account privilege, JCL privilege, and mount privilege. So going back to the top, you'll note this is using a catalog procedure called TSO in user. This is not a standard IBM thing. This does not come with MVS. This is a catalog procedure that one of those job streams in the previous step created for us. I'm guessing it's in the sys2 proclib. I think that's the right place, data set. But we can go and look at that later to see what all is this procedure doing. It ends up expanding into probably 10 or so steps for every user we create. So it's doing a lot of work for us, including creating some new empty data sets that are allocated for this user to put source code in, JCL in, whatever we want. So this is a great convenient catalog procedure to add users. In my case, I want to call my user M. Wilson. So I'm just going to change that username to M. Wilson. I guess we can give ourselves a password, let me in. Let's see, change to let me in. Account number, again, I'm not going to use account numbers on my system, so that's fine. I will give myself operator authority. I will not give myself account authority, so I can't use this user to create new users using the account command in TSO. I will give this user the JCL privilege so that I'm able to submit jobs from my TSO session. I am going to change this to no mount. We will not give this user the mount permission in TSO. And the reason I'm doing this is because I noticed in terms of in building the system that several releases ago, the RPF, I'm sorry, not RPF, RFE, the review editor, ends up causing some problems when I'm running it with users that have the mount permission. Anytime I try to edit a data set or a member, it ends up popping up a message over on my MVS console saying that it needs a volume or a device that isn't online. And then I have to reply to cancel that. And then review continues to work just fine. I'm able to edit the file. But that's kind of annoying. And I asked about it on one of the mailing lists, and the answer ended up being don't run with a TSO user that has the mount privilege. I've not noticed any problems running without the mount privilege. So I haven't bothered investigating further if the esoteric names or, the unit names on the system aren't quite right, and that's causing that interaction with review. So I'd recommend for now, just give your user no mount as opposed to mount. We can create a second user. You can see this user has fewer privileges and some different options. For now, I feel like I only need my own user, so I'm just going to go ahead and delete these lines that add the second user. We can always go back and edit this file later and run it again to create more new users. So I'll just create my one user for now. So let's save that file and submit it. So we're going to submit JCL/MVS02, move the mouse out of the way there, .jcl. And then back over in our MVS operators console, you can see that procedure expanded into a lot of steps, all of which are giving me the 0 completion code so far, which is good. Now, one of the steps that TSO in user procedure is doing is adding an alias to our master catalog so that any data sets created with our username as the high-level qualifier get cataloged in the user catalog, which is exactly what we want. So since we are modifying the master catalog, the console is prompting us for the password to allow that modification. So I will reply to message 11 with our master catalog password, which is sysprog. And now it will complete the last step, and that job finished. Then we got all 0 condition codes, so it looks like it worked. You can see here, so one of the things that job did, we're going to have an mwilson.clist, an mwilson.control, mwilson.load, and mwilson.source data sets already allocated to us. So when we log onto the system as our user, we'll already have some places to start writing our source code and compiling our load modules too. So again, a nice script that does quite a few steps for us to create that new user. If you're really interested in what are the specific commands to create users in the system, you would just look into that TSO in user catalog procedure. Now we can start VTAM, and we have a system modification that will make TSO automatically start when VTAM starts. So we have our additional 3270 session already connected to one of our TSO group. So in our MVS console, we will start net. So let's go over and do that. net. And that gives us VTAM initialization complete. TCAS is accepting logons. So let's switch over to that other C3270 session we have. And now we have our network solicitor screen. This terminal is logged on to the network solicitor. If we look back at the instructions, we see a picture of this Hercules logon screen. If you recall in the previous video, I removed the step in one of those job streams that created this custom logon screen. Just total dumb personal preference, but I feel like we're not really logging into Hercules, we're logging into MVS. It just happens that our mainframe hardware is Hercules. So I took that out just so that we could see what the default IBM logon screen looks like. But if you don't remove that step, if you like this screen, you don't have to remove that. Obviously, you can just run that job stream as is. So perhaps in a future video, at some point in time in the future, we'll make our own logon screen. But again, you can see how this logon screen was built by just looking at the portion of the job that we deleted in the previous video. So now we can log on as our user. Let's go ahead and do that. Log on, M. Wilson, prompts me for my password. And we are up and running. We are in TSO. If you know TSO commands, I can do things like dslist mwilson.star. List ds. Clearly, I don't know TSO all that well. And you can see the data sets that were allocated and cataloged by that new user script. So this is cool, right? We have a working MVS system with TSO support for users to log in. And really, we installed it from scratch on blank DazDs that we created in Hercules. Now, we don't have any editors. We have the TSO line-oriented editor, but that is quite painful to work with, even more so if you don't have the documentation handy. So we're not quite done building the system yet because we want some basic utilities, in particular editors, so that we can open the doors and really start doing what we want with the system. So I'll log off for now before I get timed out, and let's look back at the instructions. Okay, perfect. So the next thing the instructions have us do is install RPF, Rob Prin's programming facility. This is an ISPF-like editor, and we have a job stream here to install it, but this installs version 1.5.3. If we look at the website for RPF, which is moved, we'll follow the link to that. We're now up to version, scrolling, 1.7.8. So that's quite a bit newer version. It actually added some capability to edit record types you couldn't edit before. So that's pretty useful. So we want the new version. So let's go ahead and download that. This is a download that has the zip file that has a tape in it. So this will be the actual tape that we copy the RPF program from. So we'll copy that link and go into my downloads directory and download the latest version of RPF. We'll also grab the RPF load JCL. We'll need this to get the installation script off of the tape. So let's copy that link and download that file. Okay. I'm going to unzip that RPF zip file that we downloaded. So that gives me a tape image. So just for housekeeping, let's move that tape to our tape directory. And let's look at our load 1.7.8 JCL. So this is going to be a job class A, message class X. That's fine. Those all exist on our system. And this is going to copy from tape a library that contains a member called inst RPF. That inst RPF job is what will actually install the new version of RPF. So we'll keep that in mind. And let's look at what this is doing. We're running an IDCAMS job. It looks like it's deleting any previous version of the installation data set in case it's there. In our case, it's not. And then we're copying in. So the in DD is in, the out DD is out. So we're copying in from the tape our JCL library. And on our system, it's going to put it in a data set called rpf.instajcl on a volume with serial number pub 000. Well, that's fine because we do have a volume called pub 000. But as it stands, this is a new high-level qualifier, and we said we don't want to be cataloging too many new high-level qualifiers in our master catalog. We want them to go in a user catalog. So let's take a look at the job that Jay Mosley provided us. So that was it RPF? Yeah, RPF 153 JCL. So it's installing RPF. And this is actually closer to a copy of the installation script that we're going to be copying off the tape. This isn't really an equivalent of the script we were just looking at to grab the installation script off the tape. But we'll cross that bridge when we get there. The important part here is that, sure enough, early on in this process, we're defining the alias for the RPF high-level qualifier to point to our our user catalog. So I want to do that before I restore anything to RPF dot something from the tape. So let's copy this line, this define alias line, and we'll put that in this load RPF job. There's already an IDCAMS step here, and that alias command is an IDCAMS command. These are the vsam access methods. This is the program that lets you run all of those commands. So let's put that in this job. I know that we haven't done this before, so there isn't already an inst JCL. I'll just delete that line. It won't harm anything to have it, but may as well keep it clean. So we're going to define the alias RPF, and those data sets will be cataloged in our user catalog. And then we'll go ahead and restore that member from tape, or that data set from tape. Okay, so let's save that. Let me move this, again, where it is on disk doesn't matter, but just for housekeeping, we'll call this load r178.jcl and put it in our JCL directory. This way I just have in one place, all the JCL I used against the system. And now we will run that. So let's go back up a level. We use our submit script, as always now. JCL load r178.jcl. So let's look back over in our operator console. Okay, so the job was submitted. Now remember, we're adding an alias to our master catalog, so we're modifying the master catalog. So we'll reply to that message with the password for our master catalog, sysprog. And now the system is asking, can you please mount the tape RPF 178 on device 100? So on this emulated mainframe configuration, our tape devices start at address 100. And that job that we submitted is trying to copy something off this RPF tape. So let's go ahead and go back to our Hercules console and say devinit 100, because that's the device address the system asked us to put this tape on. And then tape RPF 178, the new version we downloaded, .aws. So back on our MVS console, the system sensed that we mounted that tape. We put the tape in, we hit a button that let the system know it was ready, and we copied that data off of the tape into a data set on our system. We got a condition code of 0, so we know everything worked. Now that didn't actually install RPF, that just copied the JCL job to install RPF to our system. The idea is we could look at that job and modify that job to customize it to our local system needs. Switching over to our TSO console, I'll log back in. So the problem is if we do the ds list rpf.star, list ds, I keep making that mistake. We can see that it's there. We don't have a nice full screen editor, so we don't have a convenient way of editing the installation JCL. Again, we can use the edit command, but that's a whole painful editor. I shouldn't say it is painful, but when you learn how it works, you can make changes and modifications with it. The good news is the installation JCL happens to match everything we need for our system. It's going to put everything on the volume pub 000, which is a volume that we have on our system. So we can just go ahead and run that. So I can submit rpf.inst.jcl. And then if you'll remember from the comments in that load RPF job that we downloaded, submitted, it told us the member we need to run is called inst RPF. So this needs to be around single quotes because I'm providing a fully qualified data set name. I don't want M. Wilson prepended to it as my high-level qualifier. We'll go ahead and submit that job. If we look back over on the console, we can see that job came in through the internal reader and was held. So I'm guessing on the job card, there was the option to hold the job. Well, we want to run it. So the command to run it is a JES2 command, $A, and then the job name, which I can see is RPF 178 $1. So RPF 178 $1. This was just like when we were releasing the held Sysgen jobs in the previous video. All right, we'll release that job. And, well, what is this job doing? It's trying to copy the RPF program from tape onto our system. And it needs that tape again. So now it's asking, hey, can you put that RPF 178 tape on device 101? So back over into Hercules, I'm just going to hit the up arrow because we had just mounted that on device 100. I'll change that to 101, hit enter, go back to the MVS console, and we can see that job ran. We got 0 completion codes, which is excellent, and that job ended. So now I'm going to go back to my TSO session, and if everything worked, I should now be able to run the program RPF. And sure enough, there it is. So we have RPF version 1, release 7, modification 8. We're running on OS release 3.8. You can see my user, the current time. So we now have a full screen 3270 editor. If we go into option 3.4, I can browse all the data sets. I can browse that RPF data set. You can see our installation job. So what script, what did we actually just run? Now I can look at this and I can see the steps it took. F8 is page down in pretty much everything in ISPF like land and F7 is page up. So just F7, F8 to page up and page down. We can see everything that was in that job we just ran, which ideally we'd look at before we ran it, but in the end, it worked out just fine. So F3 to quit, F3 to quit, F3 to quit, F3 to quit, and F3 to quit, and we're back at the TSO prompt. So now that we have an editor, really the sky's the limit. We are now able to write source code, and because we have that compiler pack, we can compile a bunch of stuff. So our system is really usable now. So we're done with RPF, and we'll move on in the instructions. Okay, Q. Q is a really neat little utility. It's you can almost think of it as a, what is it, SDSF on current mainframes, but SDSF very light. This lets us view our output of jobs. So in this case, I believe the version of Q that is in Jay Mosley's package here is the latest version. So in our case, it's just a simple matter of submitting the Q38J job. So let's do that. This is going to be back in our Linux shell where that submit script is that submits our JCL files. So submit q38j.jcl. Let's look at our console. Okay, looks like that job is working. It's actually loading the complete source code for this utility from a pretty huge job stream, basically a pretty huge stack of cards. And we can see that that completed with a condition code of 0. PDS load, which is a partition data set load utility. So let's look back at the instructions. It's going to tell us, okay, we loaded all of that into pub001.q.asm. There's a member in there, C, which will compile everything. So we should be able to just copy that command. And this is back to being a TSO command. So over in our logged in as M. Wilson TSO session, if I paste that in, we'll submit that job. Now, if we look back at our MVS console, okay, we can see that. So yeah, iFox 00 is the assembler. So we can see all of these assembler steps rolling by. Looks like they're all completing successfully. We'll just wait for that to finish. Okay. So it looks like that finished successfully. You see a warning here, undefined user IDs, HMVS01. The job card for this job had a line to notify the user HMVS01 when it was done. Well, we didn't create the HMVS01 user, we created the M. Wilson user. So the system is just saying, hey, I don't know who to send the alert to that this job finished, right? There is no user MVS01. That's fine. We saw it finish here on the console. So now if I go back to my TSO session, now that I know that job is done, if I run the queue program, it comes up. So again, queue is just a neat little program. If I type HO for held output, I see all of the held output for the system. So these are jobs that rather than sending their output to the printer, they just kept the job output in the spool area of JES2 here on the system. And so this is nice because instead of having to get access to the printer, which in this case means getting access to the machine running Hercules, any of my interactive TSO sessions where I'm connected from wherever in the world I'm connected from, I can actually see my job output. So I just have line commands like S, and I can go to that job and I can see its output and I can see the completion codes here. If I go back and I run, say, D, that will display all of the different output files from that job. And that's where I can see the sysprint output for each line. So for example, I can look at that with S. And ultimately, all of these together are what you'd have spewed out on the printer over hundreds of lines and a bunch of pages if this job were to go to printer output. So in queue, if you hit F1, you get the help. I recommend looking through this. F8 is page down. In particular, you can get to the page that shows you here are the letters, the line commands that you can enter on each job. And then these are the different actions you can take on it. So you can get to the message log, which is different than the JCL log, which is different than the spooled data sets. But if you are using these commands, you can get to all of the output from your jobs. For jobs that are running, you can cancel them, release them. And that, of course, requires that you're authorized to do that. So if I go back to held output, the last thing to know here is the P command purges that job. So once I'm done with it, I can purge it, remove that data from disk, and then we won't fill up our spool space. Okay. F3 to quit. And that's the queue command. So the instructions here have another brief tutorial of queue, so you can read through that. I think it probably covers what I just demonstrated. And then we move on to review. So I love review. Review is the editor I use. I use RFE, the review front end, as kind of my quasi ISPF replacement on this system, since we don't get actual ISPF from IBM. And once again, we have jobs here in the download package from Jay Mosley, but they will install an older version of review. So let's open up the review website. And this link here is a zip file that contains review. So I'm going to copy that link and I will download it to my downloads directory. And I think this is just going to litter the current directory with all of its files. So let's make a new directory to hold review and then unzip our downloaded file. Yep, so there's our review files. These are in the transmit format. So newer versions of TSO have the transmit and receive command built in. We don't have that in the version of TSO in MVS 3.8, but what we do have is a program called Receive 370 that can process these transmit files and turn them back into partition data sets. That's a utility that was on that sys CPAC disk we downloaded. So again, in addition to the compilers, there's a couple important utilities on that disk that otherwise would be kind of annoying to find and get into our system before we have some of the prerequisite programs like Receive 370 that would let us install software that's distributed in this format. So each of these is a transmit module. If we look back at the instructions, you can see that we have this load file in our JCL directory and this help file in the JCL directory. That is this review load file and this review help file. So if we look at the directory listing of our JCL directory, see we have help and load here. These were the current version of review at the time that Jay Mosley put this package together. So what I'm going to do is I'm just going to copy the current version of review over top of that existing load file. And I'm going to copy the current help file over that existing help file. And then we'll be able to use Jay Mosley's jobs to load the load modules and the help modules for review. So let's look back at the instructions. There's an explanation here of what's going on. We have a second card reader on our system, and it's a card reader that's not connected to JES2, so we don't put jobs into this card reader. This card reader is just available to us as an input device for our other jobs to use. And in this case, this is how we're going to get that load file and that help file into our system, is by putting that file just as a raw EBCDIC file, in this case, essentially a raw binary file. So we're not asking Hercules to do any ASCII to EBCDIC conversion. We're going to put that file in that second card reader. So let's do that now. So back in Hercules, we'll put that load file on device 01C. And then after doing that, let me go back up to here. Now we can submit the job that will read the data from that other card reader into our system. And that's the review 1 job. So if we look at the console for that, we can see we used that receive 370 program. So that's the program that can read those transmit files. And then it copied it into its destination. And those both worked successfully. So we're going to do that again, but we're going to load the help file. So back in Hercules, I'm just going to hit up and replace load with help. And then back in my shell, we'll submit the review 2 job. And in our MVS console, we can see that this loaded another receive 370 load, completed successfully. This loaded the review help. So at this point in our TSO session, we should be able to run the review front end. And it works. It's installed. I can go to 3.4. I can look at my data sets. We can look at the RPF data sets. So again, just like RPF, this is just another editor that's very ISPF-like. This utility, though, and one of the reasons I like review is because it also has some of the additional utilities like the out list as part of it. So if I run 3.8, so I should be seeing here the list of my held output for jobs that start with my username. And this is what I usually use instead of Q. Q has more features, but I'm often in RFE already, so it's often quicker just to look at the output from the out list. But something went wrong here. Command rev out job not found. Well, what's happening? I'm going to quit RFE here. If we go back and look at all of the files we got in that review download package, one of them is review C list, right? We only loaded the load modules and the help. There were some release notes. There were some panels. We don't need these because these are for ISPF integration on newer versions of the mainframe. We had some extra data, which was some of our installation information. We had the source code, the assembler source code. We don't really need that because I don't plan on attempting to modify and recompile review. But The review program does use some of these procedures in review CList to do some of its work. So since we only loaded the 2 using the review 1 and review 2 jobs that were provided by Jay Mosley, I want to go ahead and load the CList stuff. So let's go into our JCL directory. We'll use that review. We can use the review 2 job. It doesn't matter as the starting point. Let's call it review 3. And let's edit review 3. And you can see we are using that receive 370 program. It has to have various DDs set up. And I want to read from the card reader. So here's where we're reading from 01C. And this will be our, let's see, I believe these should be command proc. And ultimately, I want this to go to sys1 dot command proc. Now we didn't create, I should say the Jay Mosley setup scripts didn't create a sys2 command proc because there is no sys1 command proc populated with data from IBM. So normally the convention is you don't want to mess with the sys1 data sets from IBM because if you reinstall the operating system and you upgrade, those could be replaced. So you make sys2 or otherwise named data sets that your local modifications go in. However, because there was no members in command proc from IBM, we just created it as sys1 command proc, not sys2. Okay, so it looks like I need to change this help. These are just temporary names, so they don't actually matter. However, this name does matter. This is where the data from this transmit file is going to end up. So sys1.command proc is where we want it, so those are available commands for RFE to run. Okay, I think that looks good. We'll save that. Now back over in the Hercules console, we need to load that other module. So it's not in the JCL directory. This is still in my downloads review. And I think it was called revclist.xmi. Yep. And we leave the EBCDIC option on here so Hercules doesn't mess with the data in this. This is just essentially a raw binary file we want directly loaded into the system. So I'll hit enter. Okay, so that's now on our card reader 01C. So back in the shell, I can submit my newly created review 3 JCL. And if I did this all correctly, if we look at the MVS console, we got the 00 completion code, so that's good. It still says review 2 because I didn't actually change the job name in that deck, so that's why I have 2 review 2 jobs. Now if I go back to RFE, if I go 3 out list, aha, it worked this time. So now I will see all of the jobs that begin with my username. So unlike the queue program where I can see all of the held output on the system, by default, this is using the TSO job list command behind the scenes. I'm only going to see job names that start with my username. So I tend to use, M. Wilson A, M. Wilson B, M. Wilson C when I'm making my own jobs, because then they'll just show up here. Now, if you use this on the TK4- system, you may have noticed that there was a message down here that says, hey, to see all the jobs on the system, you can use ST*. And if your TSO user has permissions, you'll be able to see all the jobs on the system, and the RFE output will be able to show you those. That requires a couple of system modifications to work in this newly built system. So we'll have a video in the future where we do that. That'll be an example of using SMP to add some user modifications. And with a couple modifications, we'll be able to enable that functionality in our system. But for now, you're only going to see jobs that start with your username. If you need to see the other ones, you can always use the queue program, go to held output. And for example, these job names did not start with M. Wilson, so I didn't see them in the RFE out list, but I see them in queue when I look at the system-wide held output. All right, back to the instructions. So really, yeah, RPF, queue, and review. You're now at the point where you have a system that you're able to write code on, write your own JCL on. I love these full screen editors, and it's really a nice, pretty fully functioning system at this point for you to build on whatever you want. The one last thing that Jay has us install here is this date command. It gives us a nice date output with the day of the year number. Really, the best part about this is that if you look at this date.jcl file, it's a great example of a simple assembly program to be a TSO command processor. So something that runs on the TSO command line and can produce output for the user. So this is a complete example of the JCL to assemble and link, and then put the program output into our wherever's putting it. I think probably sys1.command_proc again, or well, no, it wouldn't be command proc, probably sys2.command_lib, to have a command available in TSO to run. So again, if you're interested in that sort of thing, I'd recommend you just read this JCL file, because again, it's a couple JCL lines and then mostly the assembly code to build this little date program. But we'll go ahead and submit that to our system. So back in my shell, we will submit JCL/date. And if we look at our console, we can see the date job came in, it assembled it, it linked it, and then the IAB update is where it copied it into its final location. So back in MVS, or back in TSO, now if I run date, we have this program that gives us the date and time in a nice format. Okay, back to the instructions. Wow, so we are almost 5 years to the day. We're 3 days later from when this particular example was made. So what next? Great question. So this next bit of the instructions walks you through an example of using RPF to create a Hello World COBOL source program and compile it and run it using the facilities provided by RPF. So you should certainly go through that. It's an interesting exercise, but it's not really part of building the system or installing new software or configuring anything. So I'm going to skip it for now. But if you're really new to all of this, this is a great first step, just to get a COBOL program running on your system, and then you'll be able to see the output of that program using the queue program. So it kind of ties together a couple of the things that we've installed when we've been building the system. So that's it. We have completed the installation according to Jay Mosley's instructions. Off the top of my head, there's probably a couple more things I'd want to do with the system, which I'll probably make the topic of future videos that are just add-ons to MVS, not necessarily additional parts to this series, which we've now completed. We'll want to add the IMON program, just because that's pretty neat. Again, also gives us another way to view the MVS console. There are some useful user mods to enable things like being able to see all of the held output if you're an authorized user from TSO, and then in turn from RFE. We might also look at adding the RACF, and that's not the IBM RACF, that's the freely available RAKF that's been made available, which is really cool. And that's a security system. And right now, every user can edit every data set on the system. That's fine for my single, my private mainframe emulated on my system. But adding the security system to it is an interesting exercise. It's also something that the TK4- system has. And so we'll be able to see how to do that, which is quite a process in itself. We might add things like KICS, again, the freely available KS, not the IBM's CI, CS. But the community has really done an amazing job of re-implementing some features that you had to buy from IBM and building them up on this pretty old, really old by computer standards, version of MVS that we have available to us. So the last thing we do in these instructions here is how to shut down the system, right? How do I perform a clean shutdown? So first, we're going to make sure that we're logged off of all of our TSO sessions. And then back in the MVS console, the first thing we need to do is stop TSO. The command to do that is ptso. Okay, TSO ended. Now TSO is the only thing running under VTAM on our system. So now that TSO is done, we end VTAM with the z net quick command. That ended VTAM. And now there are no more jobs running under JES2 on our system. Among other things, the way we can tell that is because JES2 now gave us the all available functions complete message. That means it's out of work to do. We weren't seeing that at the end of the previous jobs we were running after we started VTAM because VTAM was running, so there was still work for the system to do. But now that that's done, we can stop JES2. You'll recognize this from all of our other videos. Okay, so that stops JES2. I've noticed if you wait a minute here, yeah, there we go. It actually says JES2 termination complete and JES2 ended, which is nice. I think it's pretty safe to bring the system down just after we saw these messages without waiting for the JES2 complete, but I like to wait for it. And now we run our ZEOD, and then we run QuiS. And we can see here the system has been brought into the system wait state. When we look over in Hercules, the CPU has been disabled. So we can quit Hercules, and now our mainframe is shut down. If I go back to our consoles, you can see C3270 disconnected because Hercules, which is what it was connected to, is no longer there. So those are disconnected. The mainframe shut down. We can look at all of our virtual disk images. Again, if you like your system at this point, before you go off on your own and try and install your own software and try and change those parmlib members and really start making the system your own beyond what we've already done, again, you can back up your DazD. I'll just create a new pristine system.tar, throw the DazD images in there. And now, if I break my system too badly, I have a nice starting point where I know I'm right where we left off at the end of Jay Mosley's installation instructions with a couple of those modifications of our own. So this video is probably running pretty long at this point, but before we go, let's just go through how do I start my complete system up now, right? So I copied that config file to hercules.conf. So all I need to do is run Hercules, and that will start my mainframe with all of the devices attached. I need a console. So in another terminal, I'm going to run C3270 console at localhost on port 3270. Again, this could be X3270. This could be Vista running from your Windows box, just as long as you're able to connect to port 3270 on Hercules here to the console LU name. So that gives me what will be my MVS operator console. And then in my another terminal window, I'll connect to a TSO session. And the way we configured our system, I can have up to 8 of these. But for this case, I'm usually the only user that's going to be logged in. So I'll just usually start 1. And then with my consoles connected, my 3270 devices connected, back in Hercules, I IPL off of device 150. I go over to my MVS operators console. It asks me for the system parameters for startup. We don't usually need to rebuild that link pack area. So most of the time, you'll just hit the enter key here. You don't have any custom parameters for this IPL. It then asks us for our JES2 options. Again, in a normal startup, we don't want a cold start. We don't need to format the JES2 areas. So we just reply with 0, no rec. We see the message waiting indicator. So we hit F12 to configure our console to go into roll delete mode. And then when all available functions are complete, our IPL is complete. The only thing left to do is to start net. SNet starts up VTAM and TSO. And once we see that that's started, I'm able to go over to my TSO console and I can log on to my system and start using it. In this case, the first thing I usually do is start up RFE, and then we're off to the races. Oops, log off. So if we go back to the instructions, you can see we walked through that shutdown procedure. Another reminder if you forgot to edit your config file, but we did that earlier, so we're good. And then the last link here, actually there's some good links to various customization and assembling and VSAM and TSO tutorials. So again, if you're new to this stuff, these are all great tutorials. Even if you're old to this stuff, there could be some helpful reminders and some new things that you may not have learned the first time around. And then there's also this helpful guide here, normal startup of customized MVS 3.8. So this is just a reminder of starting Hercules. Again, we copied the config file to hercules.conf, so we don't need to provide that option. Connecting your consoles, IPLing with device 150. Normally, you just hit enter, and you normally do a warm start of JES2, and you hit F12 to get to roll delete, and you start net, and then you're up and running. And similarly, here's your shutdown steps. So that is it. I cannot thank Jay Mosley enough for these comprehensive and really high quality instructions. As you saw, just based on a couple personal preferences and newer software releases, I made some slight modifications to the instructions, but I have followed these instructions to the letter several times, and they always work for me. I know that takes a lot of effort to get instructions documented well enough that they will work even when you don't quite know what you're doing, which was certainly the boat I was in the first several times I ran through them. So thank you, Jay. I know on the first page, he's acknowledged several members of the community that did a lot of the work behind the scenes here to gather the materials so that we have the installation media, so that we have a lot of good parmlib member defaults and catalog procedures to make this whole system work. So again, you can go back to the first page of the instructions and again, just read more about the background and all the work from the community that's gone into this to lead us to the point of being able to build the system up. So I hope you found this series interesting, educational. I encourage you to do it yourself. You know, watching the videos is one thing, but then actually building your own system is quite a different thing and probably a lot more fun than just watching me do it. And then you really can, you know, start customizing your system and build your own mainframe, which, you know, many years ago would have been completely out of the question for almost all of us. So it's cool that we can do this, learn a little bit about computing history, but also have a system that works surprisingly similarly to the current latest and greatest, you know, System Z machines running z/OS. So thanks for watching. If you enjoyed this, I appreciate thumbs up. Subscribe to the channel if you want to see more content about MVS as well as other mainframe and mid-range systems. Happy to take any feedback or suggestions for other ways I might modify the system. Other videos you want to see about how to add particular software to the system. Now that we have our very own mainframe and we kind of understand what some of the pieces are, the sky's the limit in terms of what we can do. So we'll see you in a future video soon. And again, thank you for watching. I appreciate it.